This is the last video in the SQL Injection series, and instead of trying to figure out more ways by which we can use SQL injections to attack a web application, in this video we'll look at the steps we can take to prevent such attacks from being successful. In order to do that, I mentioned in the last video that the root cause of SQL injection is lack of input validation. So we'll have to take a closer look at how that works and then use that knowledge to figure out how we can defend against these attacks. So first off, what happens when we're doing SQL injection? Well, I'll go back to the slide that shows the entire path. On the left, we have the adversary who uses their browser to insert form data or cookies or any other medium into an application that is being presented by the web server. The application then looks at that input and maybe passes some of it through to the SQL database as part of the input to a query. The SQL database is going to interpret what it's getting back as a single string, and if that means that the string has been manipulated, the nature of the query has been changed. So we want to make sure that whenever we pass user input to an application, that it does not filter through to the SQL query unchanged, or at least not in a trusted way. And that is the solution to preventing SQL injection. We want to make sure that the application developer does not trust input from the end user, and that they assume that the end user does not only provide clean and trusted content. And that means that we cannot just take what the user sends into the application and use that without any form of scrutiny to create a new string. There are three main techniques to combat this, and only one of them should be used. The first one would be blacklisting certain characters from the input of a user. You might say, listen, this will never work if I can't put in a quote, or if I can't put in the double dash. And you might be right there, but don't underestimate how creative people can be. So blacklisting, filtering out certain characters from the input, is not a reliable solution. Don't worry about it, don't even consider using it. The other opposite of that would be to permit only a specific set of values being passed through. So for example, I might say that I'm only going to accept values A through Z and 0 through 9. Nothing else. That is a better approach to whitelist than it is to blacklist. But it's not the best approach. An even better approach would be to specifically tag the different parts of the query as query parts that are trustworthy and those that are not trustworthy. The not trustworthy inputs should then never be used to change the results of the database, or the way that the characters are passed into the backend. And that is what we currently recommend to do. Now, there's nothing wrong with layering it. No? There's nothing wrong with specifically tagging what parts of the query are user input and as a result should not be trusted, and a question of whitelisting where we only accept very limited input from those users. And so let's do both, but let's specifically look at parameter binding. Now, the problem with that is that the concept is universal, but that the implementation of that concept is specific to the language that you are using, and in some cases even to the particular library that you use to connect to your database. So while I can easily discuss the concepts, I cannot necessarily easily tell you how to do it in your programming language. In the CSC 260 database management system 263, database management systems course, we've looked at this for Python bindings and for Java bindings. But of course, there are other programming languages in use. This particular example is written for the PHP scripting language, like we've been using for this entire example, and expects a PostgreSQL database management systems as a backend. The way that I did it until now is the insecure way. It was a way that allowed me to do a SQL injection attack. It basically worked by taking the user input and embedding it directly into the query that we are trying to formulate. In this case here on top, I was using this to create one long query, select role from user, where username equals $username, that's the user input, and password is $password, that's the user's other input. But I didn't look at username and password at all. I didn't whitelist anything, I didn't blacklist anything, and I did not specifically tell the database management system that this part could be considered this and this as trusted input, but that what's happening over here should not be trusted. So all in all, that put us in the position that we had a SQL injection vulnerability that we did not want. The better approach would have been to do this, to use, first of all, a different function. This one is just PG query, this one is PG query params, so a query with passed in parameters. And that does it. That gives you the template for the query, clearly identifying which parts are hard-coded, this and this, oops, and this, but also specifically calling out this and this as being user-provided input. And we're not substituting in this query. All we're saying is the first user input goes here, and here's an array that contains that input. So we're passing in the user input separate from the query. And by doing that, PHP, the libraries in PHP, and the database management system can decide what to trust and what not to trust. And as a result, just by changing it from this query to this query, my application is now resistant to SQL injection. Unfortunately, many tutorials out on the internet will teach you to do this, and they'll never come around to doing this. And that means that if you learn how to program an application by just following a tutorial, you're going to miss things. You have to always make sure that you read the documentation yourself and that you maybe even look at specific documentation for application hardening. We don't want to end up in a situation where end user input is passed directly to the database management backend like it is done here. We always want to pass the query separate from the values that are being used in that query. And by doing that, we have secured our application. And that's really all there is to application security in terms of hardening against SQL injection attacks. Use whitelisting of acceptable characters if you can, and if it's predictable what those characters would be, and use parameter binding. If you combine those two, there's a good chance that you have a much more secure application than you would otherwise have had. And that's it. That's all that we're discussing on SQL injection. Right now I have the capture the flag open. That is assignment 6. Go look around in the CTF assignment. Your goal is to repeat a network scan of the target range, identify 2 new IP addresses. One of them is the CTF scoreboard. The other one is the target application itself. It is the highly insecure web application. It's a web app that I've been evolving over years and that I'm trying to stuff as many vulnerabilities in as I can. With the techniques that you have seen here and a little bit of out-of-the-box thinking, you should be able to solve 90+% of all the challenges there. The remaining 10% might require a little bit of research on your part. But have fun, and we'll see each other in class.